Valves are the heart of an irrigation system. To simplify valve installation and maintenance and ensure long-lasting system performance, it's important to understand how these components work. In this video, we'll identify the different components of a valve, including the parts visible on the outside, as well as those on the inside. We'll also show you how water travels through a valve and explain the forces that cause a valve to open and close. The Hunter PGV 101G is our most popular valve. The model you see is designed with a globe configuration, which means it has a spherical body shape and an internal baffle that separates the two halves of the body. This valve is also available in angle and anti-siphon configurations, which function the same way as the globe model. We'll use the globe-style valve in our illustrations. Irrigation valves come in two basic types: forward flow and reverse flow. Hunter valves use the forward flow design, in which water flows up from under the valve seat. In reverse flow valves, water flows over the valve seat. There are advantages to both types, but forward flow valves are generally better in low flow situations. The valve should always be installed properly into the piping system in an easy-to-access valve box. Use waterproof connectors to wire it to the controller. Most irrigation valves operate using the same basic principles. While there are some minor differences, the information presented in this video applies to most common valves. The lower portion of the valve that contains the inlet and outlet is called the valve body. The removable top portion of the valve is called the bonnet. It's generally held on by screws, but in some models it's held on by a removable ring. Some valves also have a flow control handle on top of the bonnet. The handle regulates how far the diaphragm can move up and down when water is flowing. Use the flow control handle to decrease the flow and lower the pressure. Use the manual bleed screw to manually open the valve. The solenoid is the electrical component of the valve. It receives an electrical signal from the controller that causes the plunger from the solenoid seat to lift, activating the valve. To optimize system pressure, some valves have the option to install a dedicated pressure regulation device. Here, you see the Hunter AccuSync pressure regulator, which is compatible with all Hunter valves. If we cut this valve in half lengthwise, we can see the internal components. Here, we see the inlet and outlet of the valve. The bonnet chamber, and the valve seat. The diaphragm is the movable assembly inside the valve that acts as the seal between the bonnet and the body. It moves upward to activate the valve and allow water to flow, and downward to close the valve and stop the flow of water. This spring helps close the diaphragm when the valve is turned off by assisting the water pressure in forcing the diaphragm down. This valve has a serrated disc on the bottom of the diaphragm assembly that filters the water flowing to the upper chamber of the valve. This plastic support ring rests inside the valve body. It supports the diaphragm when the valve is in the off position. There are also several ports that enable the flow of water internally: the metering port, the bonnet exhaust port, and the solenoid exhaust port. The metering port controls how fast water enters the upper chamber of the valve, which affects how quickly the valve closes. The bonnet exhaust port allows water to exit the area above the diaphragm, allowing the valve to open. The exhaust port is larger than the metering port, so the water leaves the bonnet chamber faster than it can be replaced, keeping the valve open. The solenoid exhaust port allows water to enter the downstream piping when the solenoid is activated. When a valve is full of pressurized water, the pressure is equal above and below the diaphragm. Since the surface area on top of the diaphragm is larger than on the bottom, more force is applied on top to keep the valve closed. When the electrical signal from the controller reaches the solenoid, it creates a magnetic field that draws the metallic plunger up off the solenoid seat, which allows the water on top of the diaphragm to exit the bonnet chamber and flow out of the exhaust ports toward the downstream piping. This makes the pressure on top of the diaphragm lower than on the bottom, allowing the diaphragm to lift off the valve seat and opening a path for the water to flow into the piping system. Hunter valves can also be opened manually by rotating the solenoid a quarter turn counterclockwise to lift the plunger off the seat. This opens a path for the water to flow through the valve and into the piping system. The bleed screw on top of the bonnet can also be used to evacuate the water externally from the bonnet chamber, allowing the valve to open. Depending on the method used to open the valve, reversing the order of operations will cause the exhaust port to close. This allows pressurized water upstream from the valve to flow through the metering port, refill the bonnet chamber, and generate the force needed on top of the diaphragm to close the valve. Valves are complex products with important jobs. Understanding the components of an irrigation valve and how they work can make installation and maintenance in the field much easier. To learn more about our complete line of industry-leading valves for residential and commercial applications, visit hunterindustries.com.